So we believe to stop marketing and start engaging. That's what we're doing over at DevHub. Is that now the focus is no longer just about let's sell you something on why Near is the best developer experience, which it is, right? We all know it. That's why we're here. But we want to actually start to engage you as a user and better understand what do you need and how do we help you be successful instead of us trying to put our product to you. We are live. We are back again here with another awesome workshop. This is a bonus episode of DevHub Live. I'm your host, Joe, coming to you here on this Wednesday. I am really excited about this workshop. So if you haven't been following along, we've been doing workshops all month long with different bounty sponsors for the Redacted Hackathon. And today we have another one, AI focused. This is ZetaBlock or I'm saying that right, Zeta, we'll ask them. And this is, again, another opportunity for you to integrate AI into your project and get building. And we got a great workshop today. I'm going to bring them up to the stage so we don't waste any more time, but this should be a good one. We bring up Aiden and Scott to the stage. Hey, guys, how are you?
How's it going?
Good. Thanks for coming out and doing this workshop. I'd like to kind of just start before you dive into kind of how to build on it, just a little bit about what the product is. And did I say it right? Is it Zeta or Zeta? How do you pronounce it?
I think ZetaBlock.
Zeta. Perfect. All right, we'll go with that. Great. So what exactly is ZetaBlock for developers and how can they kind of get into using it?
Yeah, so I actually prepared some slides, but I can sort of explain before at a high level what we do. We are providing a platform to sort of enable an open AI economy to allow really anyone to develop models, contribute their own data, and get rewarded for that in a transparent way. So we've actually been around for a little bit of time, over 2 years now, and we originally a data infrastructure platform, and we already provide data to several tier 1 protocols. Near, you guys are one of them. Worked with you guys very closely. Yeah.
Awesome. Yeah, let's kind of dive into it because I know there's a lot that goes into all of this, and so maybe we can start with you're going to show your slides and we can kind of walk through that first.
Cool. Yeah, sounds great. 1 second.
Yeah, no problem.
Okay, you guys can see.
There you go.
Yep. Cool. So yeah, I'll just quickly introduce myself first. My name is Aiden. I graduated from Princeton, majored in operations research and financial engineering, so pretty data science, machine learning heavy major. And I actually interned for ZetaBlock before, fell in love with Scott and Chi, the other founder. And yeah, I'm just very happy to be back and talk to you guys today about what we do and hopefully meet some of you at the hackathon. So yeah, like I was mentioning before, there we go. ZetaBlock has been around for a few years, and we've been solving data storage problems since 2022. We are a core data index provider for several protocols, including EigenLayer, SWI, Near, like I mentioned. And yeah, as of now, we already have over 200,000 data sets built by our ecosystem, over 1,500 terabytes of data readily accessible, and even now, over 10 AI use cases already in production. And we're backed by several world-class investors, General Catalyst, Hashkey. So that being said, I'm going to jump into sort of what we envision is the sort of future of AI in the coming years. And right now, the cost of developing a foundational model is getting higher and higher. And the barrier to entry is becoming higher as well. So if we look at the open AIs and llamas of the world, they're or metas of the world, we imagine that the people developing foundational models is not that pool is not going to grow significantly in the coming years, just because it's really expensive. On the other hand, derivative models, so models that are derived from foundation models, it's becoming cheaper and also just way more accessible for normal developers to be able to do that. So in the coming years, what we see is billions of models derived from foundational models. And we argue that this is actually necessary for derivative models to sort of exist. And foundational models are not enough in a lot of scenarios because they either lack domain-specific data, they're overpowered and costly for like so many scenarios. You don't need to be making, for example, like GPT-o1 calls to do specific but simple task.
Sure.
And then the privacy concern too, like sending your data to some black box API, not really knowing what's happening behind the hood there. And then also, this idea of like vendor lock-in. So, you don't want to be sort of dependent on a single closed source company. You want to have this user-owned AI. Transitioning sort of into like what we see as the next era of AI. AI 3.0 is what we call it. There's really like the huge challenge here to really unlock this new era of like open AI open collaborative AI where people can collaborate, and it's not really concentrated in just a few companies. That problem is a lack of high quality essential data. So data we see as sort of the driving force of this new AI era. And to really unlock this, there are kind of three problems that we are targeting right now and that we need to solve. So the first one is that there's no attribution and transparency. And the second one, which kind of complements the first one, is there's no fair compensation. So if you imagine someone that is like contributing their own data to some data set that's used to train a model, that data is probably high quality, but they don't really have any level of confidence that they will be compensated in a fair way. And that boils down to the fact that there's no real transparency with, where their data is going, how it's being used. And then that's also sort of leads into privacy protection. None of this is really done right now in a super transparent way where people can see like what's actually going on.
Mm-hmm.
So yeah, we see these sort of three ideas here as things that we really need to solve in order to unlock this new collaborative AI era, where there's millions of AI devs that create billions of trustworthy models, and this sort of AI collaborative economy that will sort of define the coming years. So that being said, we have built three different modules. Now, the data module is sort of what has been in production for quite some time. Consists of a highly performant query engine, data catalog, AI lake, and a virtual DB. And that's sort of our secret sauce. Our data in our data engine is really good, and that's sort of what drives the model and blockchain modules.
Mm-hmm.
And the model module allows developers to create like AI development model jobs. So for example, like fine tuning a model on some specific high quality data set that we have indexed on our platform.
Mm-hmm.
And then that creates this sort of derivative model that I mentioned before. So you've done that, but now how can you be sure that you can monetize it in a transparent way? And, you can be sure that, the usage is being tracked, all of that's tracked through the blockchain module. So once you have this model, you can deploy it on our platform, and it's tracked through our blockchain, and people then through that can actually use it for inference. And we sort of call those like the end users. So that could be like apps or other chains, or maybe individual users as well. in the blockchain. Yeah, sorry.
I was gonna ask you a question. Yeah, so we have a little bit more technical audience, so we can be more technical if you want here. But I'm just kind of curious. Can you talk a little bit about like the structure here of this infrastructure for the data modules and how this is going together? Is it something where you guys are hosting that specifically? Are you running a typical data lake, or is it something that is a little bit different? And obviously, if something is proprietary, you don't have to go into that, but just from a general standpoint.
Right. So, Joe, I can walk through more details about data infrastructure here. So I haven't done a brief intro. Maybe I can do a brief intro about myself, and then,
Sure. Yeah, please
so
do.
I'm co-founder and CTO of DataBlock, and then before DataBlock, I founded a streaming DB company. We got 44 million investment, and then before that, I was data infra team at Uber. So I was Uber engineering committee for a year and a half, supervised all the engineering design at Uber. So what we built here, actually it's two components. First is that previously, for last 2 years, what we built is actually bring the modern data stack to the crypto world, to the Web3 world. In this case, we build a lake house, in this case. So core engine, we do a modification on top of Presto. And then for data lake part, we use Iceberg, Paquet, and then we use S3. We actually don't use HDFS. I think in the future there is a plan to decentralize the storage part. But for now, we actually aim for the best performance. We use S3, so we don't use HDFS here. And then we build an additional catalog service. And on top of it, we build a call set to do the query pausing to make sure we charge the query and analysis query smartly. And then on top of this, we actually build a portable SQLite data. The reason is that most of the crypto contract data is very small. If you look at all the Ethereum data, is roughly 15 terabytes. But if you look at the biggest protocol, or relatively like majority of long tail the protocols here, most of the protocol only have like 200 megabytes data or less than 10 gigabytes of data. That's actually fitting into the sweet spot for the SQLite. So that's why we build a virtual DB as a SQLite. But we do extend it to DarkDB for more AI use case. And then that's why we build callset on top of it to make sure we analyze the query and then smartly wrote the query, AI intelligently wrote query based on the query pattern, either to the data lake or to the SQLite. Also, for the last few months, we extensively extended the lake to be actually compatible with multimodal data because with the rise of the AI, we found that there is actually a trending wave to actually not only support structured data, tabular data like crypto data, but we also see a large surface of the unstructured data. It could be PDF data, email data, this unstructured data, or multimodal data. This could be audio data, video data, etc. All this type of data. So that's why furtherly we did expansion for the multimodal data. So as of today, I think the modern modular modern data stack actually don't have a really good query engine. They don't have a really good query engine. They don't have a really good storage. They don't have a really smart indexing for multimodal data. That's what we're working towards too. Still a lot of development and then research are done in this field. And then we're happy to release more later.
Yeah, I'm glad you touched on that. That actually was going to be one of my next questions about how you're handling the different types of data like that, and obviously because it is clearly still something that is not well handled. The decentralization piece for you guys. So totally understand, like from a performance standpoint, right? Like it's not quite there yet. Is that something that ZetaBlock is trying to build its own structure, or would you actually start to build that on top of something that exists today?
So like structure, which component you're referring to, which particular
You mentioned that you guys haven't started to decentralize any of the data storage yet, and
yeah,
because from a performance standpoint, totally makes sense, right? Like it's not quite there yet for that speed and performance. Is that something that you would want to build in house to start to achieve that, or is the goal right now much more focused on what you're doing here of trying to essentially provide this platform that people can build on for the AI economy versus trying to continually decentralize everything?
that's a great question, Joe. I think from what we learned from our customer, our user, our community, people care less about decentralization, care more about trustless in this case. Actually, there is a slight difference. For example, trustless means that as long as they prove we are not mess around with your data, then they don't really care if the data is centralized in one place or decentralized in several places. But decentralized means that not only I prove that I don't mess up with your data, mess up with your query, but I also make sure the workload or job pushed to several other vendors. So I think people more care about the trustless than the decentralization. And also there is a non-trivial technical issue with decentralization. Because most of the time, when we talk about data lake or AI lake, most of the time the bottleneck is actually on data shuffling. In this case, basically just move the data across different shards to the query engine, and then this reconcile all the data and do the join part. In the commercial, like for example, in a data center, the shuffling part the network bandwidth can easily be 100 gigabytes per second or even more. Like if you're looking at the NVLink, that's 800 gigabytes per second. That's actually crazy high. But if you go through the decentralized over commercial network, you're looking at 20 megabytes per second. That's actually almost like that's actually like a 10 to the power of 4 difference performance difference. So that's why we mentioned decentralization. We actually work more on trustless, like proof of training, proof of inference, proof of SQL, and instead of like actually decentralized payload, because I think people care less about that part.
Yeah. Yeah, that's great to hear, and it makes a ton of sense. I think a lot of companies that we've been talking to seem to have the same sentiment that users right now are much more concerned about, like you said, trustless, but also performance. That it's hard for me to build on top of something that does not have the performance that I expect. So great. Sorry to detour there a little bit, but I just wanted to dig a little bit deeper as we were going here.
No worries. I think this is an excellent question, and this is actually the question we're facing every day. But people, I think when people talk about decentralization, the really thing they care about is trustless instead of the decentralized. Yeah.
Yep.
Cool. So yeah, going into sort of more of our architecture, we're not going to go into sort of every component here, but the stuff in the blue, that's what we have had in production for over 2 years, battle tested with industry leaders. And that's sort of what we would consider our unfair advantage. A highly performant query engine, the AI lake like Scott was talking about, to process really any type of data, structured, unstructured, multimodal at a huge scale, as well as like portable AI memory. And then what is in the red box here is our AI network. And that consists of the 3 modules that I've talked about before, data stack, AI stack, and blockchain stack. So data stack is complete. We actually launched our DevNet as well, so everything in the yellow is complete here. And the red is for the mainnet, so subnets and verification module that is to come soon. So yeah, going into the actual hackathon here, why did we sponsor this hackathon? Well, given everything Scott talked about and everything I've talked about, sort of thinking about this open AI economy, we imagine that it's going to be driven by individuals and small groups that want to collaborate. And we thought that this hackathon would be a great way to sort of reach out and engage with these types of people who will likely be powering the next era of AI. Also, shout out to Near and Delphi Digital. Recently joined their incubator, and then very excited to engage with the community and developers there. So actual numbers here for the hackathon. For us, there are 2 eligible winners. The total bounty is $2,000, so it'll be $1,000 for each winner. And the actual criteria for us, in addition to all the criteria for every project in the Near Hackathon, what we're looking for is to build a dApp or a use case that's relevant to AI or uses Web3 data in some way. So some examples of this could be like building an agent to speed up dApps on Near. The process of building dApps on Near. Another one is like a blockchain live news digest agent. So for, imagine you give it some natural language query, And then in the back end, it generates a SQL, retrieves the data, and then summarizes it back to you in natural language, or like an on-chain trading fraud detection-based AI model. So those are just, 3 examples, things that, could work with us. And then the question is like, well, what are we looking for in a project? What are the metrics that we're gauging? And the main metric that we care about is just what we call like the wow factor. Like, how interesting is this project? How novel is it? Is it doing something that's meaningful and that, hasn't really been done before in a lot of different ways? So note that this doesn't really mean that you use a ton of compute to train like a highly performant model, or you have access to some really exclusive, expensive data set. That's not what we're looking for. We're looking for creativity. So how you want to take that is sort of up to you, but that's sort of what we are looking for in projects at the hackathon. So yeah, let's do a short example of something that is sort of within the realm of like what we're looking for here. IP infringement. So the idea here is that some entity will have registered IP data that they don't want other people to copy or use. So an example of this could be like Disney with their many different characters. So you have this data and you say, okay, I want some model that can detect when an IP infringement has occurred, and then maybe, raise a dispute or something if it has occurred. So to do that, you need these 3 different types of data. You need the registered IP data, so the stuff that you don't want people to copy. And then you need positive samples as well as negative samples. So positive samples, it says, all right, if you see this image, then it's probably an IP detection, and a negative sample is something that should not be really related to the registered IP data. And the goal here is for some model to like learn the boundary between positive and negative samples. So in this scenario, these 3 types of data are probably coming from 3 different entities. So you have these 3 data contributors, and then as well as like a model builder. So someone who uses the contributed data and actually builds a model off of that and then deploys it on our platform. And then it's used by model users. So people who want to use this to see if any IP infringement has occurred. So that's what a typical flow might look like. The model user typically will pay for inference, and those rewards will get distributed back to the model builder as well as the people or entities that like contributed their data to allow this model to be trained.
Let me ask a quick question here. So in this example, which, I guess, as a hackathon participant, because we're talking about that specifically, am I just building a part that is using the model, or can I also make my own model based off of data that's been contributed? Where does that all fit?
Yeah, I mean, it's pretty open-ended. Like the example I'm showing is actually making the model, and showing how it can be used to calculate like when an IP infringement has occurred. There's no reason though that you can't make an agent on top of that that underlying it has some IP infringement model. We're showing sort of like a base example here, but yeah, like a really good project would probably have some agent involved in there that could like raise and resolve disputes as well.
Got it. Okay, cool. So you as a builder really can kind of own the entire flow here.
That's right. Yeah.
Awesome. Yeah. Very cool.
And also, just to mention again for the data aspect here, we're not looking for a really high quality, expensive data set. We're more focused on the idea, the intention, and the execution. So yeah, let's do I'll do a code walkthrough here. So this module notebook, I'm not going to go into this. This defines like the model architecture, the training process, various like utility functions. I'm just going to walk through like, how we actually train this model and show it, how does it actually perform for inference. So in this case, we want to train a model to basically say, all right, here's these different pictures of Elsa from Frozen. If you see another image like this, that's similar to this, then an IP infringement detection has probably occurred. So what this actually looks like is it's a small data set for this example, but we have 5 training images, different pictures of Elsa. Here we initialize our model, then train it on each of these images. And then, it takes not that long to train, it's 5 images. But at execution time or at inference time, we give it a test image, so something it didn't train on. And before I show you the actual score here, this probably should throw an IP detection or an IP infringement detection. And if you look at it, it does. It's a pretty high percentage. It's you embed the image and then you do a cosine similarity. That's like underlying what's happening here. And it also gives you like the most similar image in training. So it's not only like, an IP infringement has probably occurred, but it's like, yes, an infringement has probably occurred, and this is the image that's most similar to it. And then if you want to see, how does it perform with a generic, princess in a blue dress with a white background, this probably should not throw an IP detection. And it doesn't. I mean, it's a pretty low percentage there. So we can keep showing examples here. Cinderella gives reasonably high. Just lady in a blue dress gives really low. And then Elsa in a different sort of aesthetic here, cartoon, gives a reasonably high, percentage as well. So that is, again, it's a simple example, but it shows sort of what we're all about, and how in the future, we'll have these 3 different sources of data: a model developer, a model user who pays, and then rewards can flow back. And this is within the realm of like what we're looking for this hackathon. Mm-hmm. So any questions on that one?
Yeah, can we go talk a little bit about the existing data sets that are there? So is that, if I come in and I want to start building, is there opportunities for me to leverage existing data sets? So whether it's on-chain data, or I think I saw like you guys have maybe like Twitter or something like that, data integrated in there. I can just pull that as part of the process here. But then if I want to specialize, I can then also add my own small data set to do additional training into a custom model. Is that right?
That's right. Okay. Yeah.
Actually, we build a fraud detection use case on top of existing data set. I don't know if Aidan, you prepare for this. If not, I can do a sharing for existing, on-chain data, etc.
Yeah, I'll stop sharing, Scott, if you want to.
Oh, sure. Give me 1 second. 1 second here.
Yeah, also, Scott, if you want, I'm happy to explain it too.
Okay, sure. So we did, let me share my screen, and then I just got it ready. We did, so let me share my screen for the existing data, and then I can go through, talk about more about like how we can help use existing data to build a fraud detection. Can you guys see my screen now?
Yep.
Okay, so first is that we have a bunch of the on-chain data, like Ethereum data, Polygon data, Solana, all this data, and then Beacon data. We're actually going to further expand it. First is that beyond crypto data, and second is that we're actually going to release more about multimodal data processing as well. But just for the blockchain data, I can do a quick fraud detection use case we build internally. So the idea is very simple. Like giving a transaction hash, I can go, for example, to Etherscan, give a transaction hash, and then to identify if this transaction hash is a fraud or not. This is actually a fraud transaction, trying to just basically exploit abracadabra money this earlier January this year. And then in this case, it's a fraud. And then what we do is that because actually when you build a model, 90% of the time, 90 or 95% of the time is actually building this data preparation and data filtering. So first is that we transform the data, convert the transaction hash to a payload in this case. So basically that transaction hash is converted to this payload. This payload is actually saying who is transfer money to who in this case. And then on top of this payload, we build a model. We build a model for this, and then basically feeding the data and treat each wallet address as a special token. It means that instead of say, hey, who is 0x1234, which is say, hey, 0x1234 is a concrete person or concrete entity or concrete token here. And then we feed into a model and train a fraud detection model in this case. We partner with auditing platform to provide us roughly 2,000 data point here. And then once we have the fraud detection, because in this particular case, we want to optimize for recall instead of accuracy. So in this case, we tune a little bit to make sure recall is 80%. If we optimize for accuracy, which is not ideal for this scenario, the accuracy could be like 99%. But because we optimize for recall, we tune a little bit, making 80% for both. So once we have the model, now you have a model which is usable. For example, in this case, I just copy paste the transaction hash here, and it immediately tell me it's a fraud transaction. And once you have a model, it's actually quite simple to do any of the transaction detection. For example, I can go here and then find this transaction hash happened just seconds ago. And then I can come here and then say, hey, could you tell me if this transaction is fraud or not? I can just copy paste the transaction hash and evaluate immediately. So it will give me a very high confidence level it's not a fraud, because the pattern, for example, if we copy paste the pattern here, the pattern for this transaction is very different than the pattern we saw in the past. So you realize this is unlikely to be a fraud transaction. So all this is actually enabled on our platform as of today.
That's really neat. And so for one, I guess, again, from a hackathon standpoint, developers who are not maybe comfortable with fine tuning they're not really in that part, they can just jump in and start leveraging some of the stuff that's already here. Sounds like, which is great. Two, it looks like, just from what you're just showing me, that the act of actually updating these models a little bit doesn't seem overly difficult here. It really just looks like small blocks of Python code to really get across like what you're trying to change. Is that right?
Exactly. So if we break down all the steps for training, the most important part is data preparation. That's actually 90 to 98% time, 90 to 95% time. So that's why this work we actually referring to UC Berkeley's research called BlockGPT. We built on top of a research result, and then we follow the similar methodology here. And then basically, majority of the time is massage data. Then once we have the data, and then the training here is more like a boilerplate code. And this happens to almost all the AI use case. 90% time you probably spend massaging the data and find the right data and then clean the data. And then there is some hyperparameter fine tuning, but there is actually like a formula for it. You can just tune a little bit, and then basically majority of the time you just tune for the trade-off between accuracy and recall.
Now, you guys mentioned that because you're actually leveraging based off of these base models, do I, as a developer, have a choice of which model I'm going to use?
That's a really good question. So it really depends on use case. Like for fraud detection, if you look at the fraud detection, most of the Llama model, Gen AI model, you cannot use. For this particular fraud detection, we actually use BERT model, because BERT model has a classifier. In this case, you can say distilled BERT model. It has a classifier, but model choosing and also how do you actually design your structure? This neural network structure, write that part of code it requires some experience. But once that part is settled, the majority of time still focus on the data, tuning, data preparation part. Yeah, but model, foundation model choosing is actually a big part in this part. Yeah.
Very cool. Very cool. So the agent part of this, so a lot of people have asked us about different agents. We have a few different companies come on, talk about building agents. So can I just jump in and just start building an agent as well?
Well, that's a really good question. I think the agent here is model plus perceptor plus actor here. And then in this case, I do saw a very popular project recently called on Twitter. There is a very popular project. It just keep AI generated tweets. In this case, you can build a large language model, percept all the new Twitter tweets, and then do the action as integrate with the Twitter API to the Twitter tweets. From that perspective, I think everyone can, as any app developer can integrate with a third-party API to make a model to to an agent in this case.
Nice. Now, all the stuff that's here, what is the setup for a developer? Do I need to pay? Is it like kind of like a SaaS service? Can I just dive in and start playing with it? What does that look like today and maybe in the future?
Oh, sorry, Joe, could you repeat the question?
Yeah, so to start using ZetaBlock and building on top of it, is it like a SaaS model where I have to buy credits and start building, or can I just kind of jump in and see what, play around with it for a while?
Sure. So I think everyone is actually give a $50 per month credit, a $30 or $50 per month credit. It probably cover majority of part. We're actually going to change our business model to a token-based model as well. So currently it's SaaS model, but we're going to change it. We're going to launch a new protocol and change it to like a token-based model very soon.
Nice. Okay. And one of the things, and I know this is not related necessarily to the hackathon, but just kind of my own curiosity of just how you're structuring this. So part of it is with the blockchain model was being able to make sure people are compensated for things like the data sets and models. How is that all fitting together? And as a developer, if I'm bringing different things to the table, is this an opportunity for me to earn as well, or is my focus really just on building an end product?
That's a good question. Aiden, do you want to answer this part?
Yeah. So model builders, as well as like people that contribute data, the idea here is that you may do it because you want to do something useful. You want to fine tune a model that solves a specific use case. But the angle we're taking is just very collaborative, in the sense that like I have something I want to do, but I don't myself have the data to do it, and maybe I don't even have the technical expertise to develop a model. But in this sort of more open AI economy, I can find someone that has the right data. I can find another person who can develop the model. And then I can pay for inference, and the rewards can flow back to them for their contributions.
Very neat. That's really neat. So long term, it sounds like that really the goal here is, maybe it's not the best word for, but it's more like democratizing the ability to build AI data sets. So, right. So again, like you said, it's not about decentralization, the fact that like there's all these nodes running everything, but the data is trustless. Everyone can contribute. I am compensated for my stuff. It's eliminating the things that are people I feel like are getting frustrated with the more centralized things, where they feel like those are all just kind of ingesting and taking, where now it's a two-way street here.
Yeah, exactly. Yeah. I mean, yeah, you're, as an individual, your data is so valuable, and there should be an easy, transparent way to actually earn based off of that.
So we figured out, as Aiden showed earlier, in order to reach AI 3.0, the next biggest gap is all this data. I'm not talking about Wikipedia data. This is actually like all the image data, video data, like for cancer detection data, or it could be like AI girlfriend type of data, and then could be some robotic data, in this case, robotic data. This type of data is actually, great, basically just in great demand. But on the other hand, the data contributor side, they have no way to contribute data confidently. If they upload the data in Hugging Face, they basically give the data for free. And then if they list the data elsewhere, they don't know how to charge the data as well. Should I charge 50K? Should I charge 10K? Or should I charge $1 million, $2 million? It's very hard to charge the data. So what we provide is a trustless platform. So model builder can use the data to explore the data, but they cannot download the whole data set. They can explore the data, they can build the model, they cannot download the whole data set. But once they build the model, they don't need to pay a big upfront fee. they can just build the model and use the data set. So every single inference fee will go give a percentage back to the data contributor. In this case, the data contributor don't need to worry about mispriced data, mispriced data, and model builder don't need to pay a huge upfront fee for the data set.
Yeah, that, I mean, makes a ton of sense to me to start building that way. And do you feel, and this is just purely from a philosophical standpoint, this allows for better, more recent data because I know I can both have control and be compensated?
That's right. I think it's going to be, it's much easier. Actually, we're working with 10 plus business partner to provide the data. In this case, their data is more, massage, and then they actually need to remove some sensitive information as well. It's a little bit harder to get data from community or individual user because that's actually, massage data, make the data usable, categorize data, filter data is a lot of work in this case. So that's why we start with business partner. But I think in the long run, community contributed data is possible. This is particularly true for some multimodal data.
Makes sense. Makes a ton of sense. I'd love to just kind of before we wrap up here. So I have the link to your docs down below. Can you just do like a quick maybe overview of like what's available in your docs? Kind of getting started. What do I need to have ready to start building something?
Sure. Yeah. So let me briefly walk through the doc. So the currently, just let me share my screen again. The existing doc is actually focused on the data infra product. So in this case, we have a different recipes to actually use the data, send SQL query, or build a backbone for the like indexing the data, build a backbone for your application here. And then we have some pre-built API for you ready to use. And then one of the key thing we support is that you can easily convert a SQL to a GraphQL API. There is also a detailed description here. So how to convert the SQL to a GraphQL API here. So all the AI component, we haven't released it yet. So all the AI component, including the training the data, training data and inference of the model, etc. We haven't released it yet. We target to release at the end of the November. And then we're going to have an early release for first 100 developer or first 100 business partner. In this case, like the developer or community member. We're going to release in phases, and then I think the first phase of release probably going to be around sometime in November. So if you're interested, please sign up in the website, and then we're going to release in batch in this case. But for all the existing data product, there is a comprehensive developer doc. And then you can just come here and then sign in to use. And then currently we don't require you to it's a beta, open beta access, so you can use the existing data infra product self-serve.
That's awesome. Yeah, I wanted to make sure we showed, because I think for developers, again, from like anecdotal from conversation, like some people are still kind of skittish when they hear AI. They think, oh, I'm not that level of programmer, I don't know Python, whatever it might be, but like they can get started. You have APIs. If you know how to ingest a REST API, if you understand GraphQL, like you can be off and running and doing something really pretty cool right off the bat right now. So I think from a hackathon standpoint, it feels like that's kind of an easy way to go at the bare minimum.
That's right.
Awesome. This was great. I'm certainly very interested. I hope people really got something out of this. There is so much cool stuff happening on the AI front here. I'm glad you guys are part of the Near ecosystem. This is a really great advantage. I hope people take time to check this out and start building on this. Any last kind of thing we want to leave people with? Again, we'll share all this out, make sure people kind of catch up on this, but anything else?
No, yeah, I think I'm good on my end. Yeah, I hope to see a lot of you in Bangkok. Should be fun. So yeah, thank you, Joe, so much. Appreciate it.
Yeah, no, my pleasure. Scott, any last words?
That's all from my side. Thanks, Joe.
Yeah, no, thanks, guys. I really appreciate it. And again, folks, if you haven't checked it out, go on and check it out. Appreciate it. Thank you.
See you guys.
Yeah. Folks, I hope everyone took some time to check that out. This is, again, now we've had a few different AI platforms come on here, and I want to take a second here and actually just kind of go through again some different things that if you're building and you want to start hacking, we can certainly jump in, right off the bat. And let me show you something here. So let's jump in. So as Scott was showing here, so in the AI documentation here, I'm sorry, the API documentation here, again, when we talk about building a product for a hackathon, one of the tips that we've continued to harp on here at DevHub is like, don't try to do too much. Like, don't try to over engineer. And here's a great example where I can take maybe an existing product, I can take something that maybe doesn't quite exist yet, and I can jump in with their pre-built APIs. And right off the bat, if I need to pull in different data sets, right, from chain data, like that's an easy one. Like the example they just walked us through here with fraud detection, all of that stuff is readily available. I can start pulling in some different information. If I'm doing something with chain signatures, I mean, let's start putting those pieces together, right? If I'm building with chain signatures, if I'm doing stuff across chain, and now I want to pull in some other data, in real time, through this, and I want to have a model that maybe is, again, whether it's fraud detection, whatever else it is, I can start pulling these pieces together. And from a hackathon standpoint, now like you're integrating AI, you're integrating a chain signature, you're integrating all the different components that you can all apply to try to win prizes. And so to me, I feel like this is something where we're not just saying like, hey, check out these different platforms for the sake of doing it. It's really because it gives you an opportunity to really expand your product a little bit, maybe think a little bit differently outside of what you're trying to do, and see kind of where things kind of go from there. One of the other things here too is that, again, you can actually, as Scott mentioned here, you can actually jump in and do some custom calls as well. And that's again, if you're comfortable writing GraphQL stuff, that's really powerful as well. And overall, I mean, I haven't really had time to check out the recipes just yet, but I mean, really simple stuff to kind of like query to a real-time database in JavaScript. Like here it is. Like it's like if you're working in JavaScript, here's the recipe. They're making it super simple for you, and you're off and running. And so I think these are just, again, like really great opportunities for everyone to jump in. Overall, let's check out while we're here. So if you have not seen this, again, the Redacted Hackathon, all of the different prizes are down here. And, we just talked to Zeta Block. And so here they are. Here is, just highlighted everything. But you can see all the information here. And now this is, again, where you can start pulling different pieces together and seeing what other bounties are there that kind of make sense for you. Tons of great resources all up here. We have over 1,300 participants. There's plenty of time. If you haven't seen, the deadline has been updated to October 31st. That's a lot of time still to go out and build. A lot of this stuff that we've shown on these workshops can be built, at least get started in a weekend. Like absolutely, like you can dive right into this. So really take that time, jump into there. If you are unsure, if you have an idea that you want to just run by someone, really come to any of our different chats. So if you go to the resources and you come in and you want to jump into any of our different groups, we have Telegram groups here. Jump in there, ask some questions, share your stuff. We're all here to really help each other. At the DevHub standpoint, we want to make sure that you feel really comfortable with everything that you're trying to do. If you need technical help, we're here. And so come ask those questions. Come walk through some of this different stuff. We understand that sometimes it's hard to have a good idea for hackathon. So, jump right in and please ask questions. We're available, obviously, again, through our Twitter as well if you don't use Telegram, and you can message us there as well. I will say, if you haven't already as well, make sure that you are looking at the general, frequently asked questions here of what are we looking for in the different projects. A lot of opportunities to win prizes. Again, over $700,000 worth of prizes. So there's something for everybody. I think it's a great opportunity for everyone to jump in, even if you're not a builder, you're not a coder. Find a team, brainstorm. That stuff is just as important. Presentation is important as well. All those things. So, great way to get started. We are back. So we will have our regular scheduled DevHub Live next week. It's not next week. Tomorrow. The day is only Wednesday. Tomorrow on Thursday, we will have again a special bonus on Friday evening. We're going to do a DevHub Live coding with Frohl. He is one of the early developers here on Near. We have Meta, and he's going to walk through and he's going to do a to-do app on Near just to show how the contracts work, all that stuff. It's going to be a great time. So your Friday evening is all set. Book it down. And then Monday we have MetaPool. So they have a liquid staking platform, but it's so much more than that. And so really make sure you're following all the socials here on Near Protocol, Near DevHub, so that you can stay up to date. We have a newsletter. The link is down here below. Every single week, we have great updates for developers. Everything that's going on in the Near ecosystem. So make sure you take some time to sign up for that. Get a quick summary of, what hackathons are happening, how you can help, how you can jump in. What do you need to know to be a top shelf builder here on Near. With that said, this was another awesome workshop. I'm super excited. Everyone got to see what they're building. Again, we will have even more great stuff all the way through the end of the month. So keep building, keep hacking. It's going to be a great October here, and we're excited to see what everyone builds. But until then, we will see you again tomorrow. And I am Joe, your host for Near DevHub. See you later.